What is up, boys and girls? Welcome to the next episode of Blocker. And of course, I wish you a very healthy and wealthy 2023. It is what it is for me. It's just a new day. It's just a new day at the office. For a lot of people, 2023 is a new year, new me. And I think it's bullshit. I think if you're waiting for a new year to change your life, you're wasting so much time, right? Of course, setting a goal, changing your life is always good, but I think changing something in your behavior, changing something in your life, it doesn't matter what it is. Maybe you want to be a better person, better coder, a better human, whatever. You can do it at any time, right? It does not need to be a new year, right? If you want to go to the gym, you don't need to wait to the new year. You can just go. It is what it is. Okay, so basically in the previous episode, we did some stuff, right? So let's open up chain test, right? Because there is where the magic happens. So we have this whole shebang, right? And I'm still a little bit of a cough because I had the flu and all that stuff. It was nasty. So we have test add block with the X, right? So we do all that stuff, making our outputs, inputs, and all that shenanigans. And the problem is that we need to do a little bit more verification of these transactions, right? Verification, in my opinion, is verifying the signature, and then validation is some other stuff where we're going to validate the UTXOs and all that stuff, inputs, outputs, right? And we also need to do the Merkle tree and all that stuff. We will see how far we are going to get. All right, so basically, let's open up chain, because in chain here we have add block where we do, what is this? Let's delete that. We have this TX transactions, and then we're going to store the transaction into our memory, into our database, and in this case it's going to be a memory store, but we can swap that out. Where is our validation? Here, validate block, and then we have validate block here. So the question is, where are we going to validate that transaction or verify? And I think maybe we could do it in validate block, right? We could verify the block here, and then do some stuff, check the current block, check the hash, and then we could say for_tx in a range B transactions, right? We could do something like if types verify transaction, the TX, right? And if that's not the case, we can actually return fmt error f, and we're going to say something, what's going on here? We can say something invalid. Man, what's going on? Still early. Invalid TX signature, something like that. Yes. Right. If we run this should actually fail, right? Make test. It's passing. That's crazy, not gonna lie. Verify transaction. That's crazy. What's going on? Chain test, let's open it up. Because if we have this thing here, we actually don't sign this thing. We don't sign it, so that should be an error in my opinion. Let me test this real quick here. What is going on? Transaction. Let us check what's going on here. Verify transaction. So we arrange into the inputs. Sig verify. Add block. This is add block small caps. But refers to validation here. Yeah. If types verify transaction, we're going to return an error. What's going on here? What is this? We are not... We're not going into that thing. What's going on here? Add block. I see what's going on. We do add block here with the small caps. That's not true. That needs to be the bigger caps. Yes. And that should actually be better. Make test fail. That's good. The length of the bytes, yes, that's fine. Because the reason why we have this error, the length of the bytes not equal to 64, that's because we don't set a signature. So, to be honest, I don't like that error. I think we could do something here if len input signature is 0. We could do something like, we can actually panic here. Let's do the transaction has no valid, has no signature at all. Signature, boom. Just like that. And then if you do make test, then we're gonna see this. The transaction has no signature. That's fine. So let's sign it, right? Let's sign it first. Yes, it's gonna be some complicated. Like I said, it's this whole unspent transaction model is nasty, but it's very, very secure. Because you can see there's a lot of stuff needs to be done. So basically, what we're gonna do here is these are our inputs, outputs. We're gonna sign this transaction. We're gonna say signature. What's going on here is going to be types sign transaction. The TX here with the perif key. And then we're gonna say TX inputs 0. Signature, string not string, signature is going to be sig bytes. That's that, right? So that's good. If we test that, boom, that's gonna work. So that's fine. Yes, the next thing we're gonna do in chain is basically we're gonna verify it. We're also gonna check if it's spent or not spent. If it's already been spent, that's a problem, right? And I think we're gonna extract it into another function. So enable to check if it's spent or not spent, we're basically gonna keep track of the unspent transaction outputs, right? So I think enable to do that, chain is gonna be a good starting point. Where is chain? Here. So what I'm gonna do real quick here, I'm gonna say type UTXO. It's gonna be a struct, right? We're gonna have a hash, which is gonna be a string is fine. We're gonna have an index, which is an integer. We're gonna have an amount, which is gonna be an int 64. And we're also gonna have if it's spent or not, which is a bool. This index is basically the index of the output. Let's make it out index, right? Let's make it out index. That's a UTXO. Then in chain, when we're gonna have something like a block store, TX store, we're also gonna have a UTXO store, actually, to be honest. That's a good question. It's gonna be a UTXO store. Damn, that's nasty. We need to go to store and implement that once again. Actually, to be honest, can we copy this? UTXO store error. We're gonna say put and get. I think it's fine. What are we gonna store? A UTXO, right? There's gonna be a UTXO. And we're gonna get that by string. That's fine. So it's gonna be a UTXO. Type UTXO memory UTXO store. There's going to be a structure. Damn, we need to have this lock again. It's nasty. To be honest, I think we can make this a generic thing, right? Because we will refactor that. We need to refactor that because now we are basically creating all these interfaces and we can actually make something generic because the only thing that actually changes the underlying data, right? But hey, so we have a memory UTXO store. We're going to say that the data actually is going to be a map of string mapped to UTXO, right? That's what it is. And we're going to say func new memory UTXO store, which is going to return UTXO store, just like that. We're gonna return. You see, it's always the same. We're gonna swap that out very soon, and then we're gonna say that the data is going to be make me a map of string mapped to UTXO, just like that. And then we're gonna basically do this. Get hash string is going to return a UTXO and an error, right? Let's copy this, paste it in, and it's going to be put, and we're going to put basically the hash. Do we? Yeah. Do we need a hash? Yeah, we need. Wait. Yeah, I think we can do a UTXO. Why not? I think we can. UTXO. And it's going to be an error, right? Let's return nil here. So for getting this thing, it's very simple. What we're going to do is we're going to say sLock is going to be a read lock, right? The error lock, right? Just like that. And I'm going to say here defer sLock unlock. And then what we're going to do here is UTXO OK is going to be as data hash like that. If not OK, and it's going to be percentage %s. It's going to be this, right? Nil. And in that case, we're going to return the UTXO and an OK, not nil. Boom. Right, that's get. And for putting is the same thing, right? So we have this UTXO. It should have a hash. So what we're going to do is sLock. It's going to be just a lock. And we're going to here say defer sLock unlock. And then we're going to say as data hash is UTXO hash is going to be the UTXO. Just like that, something should be perfectly fine. Right, so if we have our UTXO store here, it's going to be a UTXO storage. Damn, we need to have all this bullshit. Yeah, what I'm gonna do is I'm gonna hardcode it in real quick. Instead of passing it as an argument here, I'm gonna hardcode it in because, yeah, we're gonna change things up anyway later on. We're gonna say UTXO store is going to be a new memory UTXO store, just like that, and call it a day, right? Okay, so now we have something to store the UTXOs. When are we going to store the UTXO? Well, when is it unspent? It's when we are creating that as an output, right? If we are using it as an input, then we know it's going to be spent. But if it's an output, it's gonna be unspent unless it's going to be used as an input, right? So So we are storing this transaction here. What we could do is basically say that the UTXO in this case is going to be, what's going on here, is going to be an UTXO. The hash is going to be, that's going to be a string, right? So we could say that the hash is going to be hex encode to string types hash transaction tx, right? That's the hash. Now we have the amount. Damn, we need to loop through this thing actually. We're going to say for underscore, it's going to be output in range tx outputs, right? Like that, because we need to make it for each output. The amount is going to be the output amount. Just like that. Then we're going to have that we need this iterator here in this output, right? We're going to say that the output index, right? The out index is it, right? And then we're going to say that spent is going to be false, right? But we're going to make, of course, Golang will make it false by default, I know, but this is basically for me a little bit more verbose, right? It doesn't really matter. And if people are going to complain that you're not waste anything, right? People are wasting their time complaining for these things, right? It's just clear, spent is false, whatever. You could delete it, you could place it in. Hey, if you, whatever, you're the Bob Ross of your painting, right? You can decide if there is a little happy spent variable there. That's UTXO, and then what we're then gonna say is we're gonna say that cchain UTXO store. We're gonna put this thing UTXO, right? We're gonna put that thing. We're gonna store it, and that's gonna be an error, which basically is not gonna return one most of the time, but still we're gonna handle it, right? We're gonna say return add actually if that happens, right? That's cool. That's cool. Is this gonna work? Okay, there's no problems, so on. That basically means that if we go to chain test, right, and we're gonna use the same test here. The question is, are we doing this for the Genesis block? Good question. Check if there is an UTXO that is unspent. So we're going to say UTXO hash is going to be chain UTXO get where is the hash? Takes hash, you see it. Assert nil t hash assert equal t UTXO. Actually, what do we want? Let's do an amount. That's going to be we have two inputs. We have two outputs, right? So we're going to have so he can spend this and we can spend this back, right? So we're going to have yes, I see what's going on. We're going to have a couple UTXOs. Wait, I'm in trouble. I'm in trouble. The reason is because look at this. What we're going to do is let's print this guy out actually. Print ln UTXO. Let's do it here actually. Run the test. You see we have a UTXO, right? And it's the 900 one. It's basically the last one because it's overridden this one. That's actually bad. Huh. Okay, how can we fix that? Because we're gonna check for the transaction. Check it as it is only unspent. That's true, that's true. But there are two unspent, right? So we have this amount 100, which we send to the recipient. So he can have that as it's basically an unspent output. He can use it as an input in his next shenanigans, right? Because we send it that money. And then we have 900 and we send that back to us. So we can use that to spend once again. So how are we gonna fix this? That's a good question. We can fix that by we could do. Wait, there are so many things we can do, to be honest. Let's open up chain, because we are storing this UTXO and we are storing it in a hash. Because it's going to be the transaction, the TX hash, right? But we could do something like TX hash and then concat this with the address. Or actually do this. Address TX hash. Right? Because then we can fetch all the yeah. Because that way we can actually fetch all the unspent for a particular address. Right? That's what we could do. So the hash is fine. But we store it. We could do something like fmt sprint. We could do %s underscore %s. And we could say it's going to be the output address. Question about is how do we... It's not a function. What is this? Damn. What is this address? It's going to be a byte. We don't want that, right? We're gonna what we could do is, can we do crypto address? Damn, don't we have that in keys? Bytes, private key, public key from bytes, address, signature from bytes, verify, address, Let's make a function. Let's call it address from bytes, B, address, return, value B or something. And then we could do something like this. Paste this in, and we're going to say it's going to be address length. Length of the bytes not equal to what's address length? 20. We're going to call this address like this. Address from bytes. It's going to be the output address, right? Because then we can make the address like this. And then the hash. The problem is, actually equal to string, that's fine. That's fine. That's the key, and let's store it as the key like this. Boom. What's going on here? Cannot use of type string. Shit. UTXO store. This is actually on the fly, guys. On the fly. So if we put this UTXO, the problem is that we don't have... let's make a key here then, I guess. The problem is, do we do keys? We should, man. We're gonna say key, string, UTXO, that other thing. So UTXO store is gonna be put string this. Boom. That's what we want. Memory UTXO store is going to be key. Right? I'm going to say key UTXO. Fine. It's going to be this. Yeah. Chain test, eh? So what we're gonna do is we're gonna say this UTXO is gonna be chain store get. It's gonna be a TXI. That's not true. So we're gonna make the key here, and the key is gonna be. Maybe we should. What's going on with this keyboard? Oh, this is so nasty. I'm not gonna lie. Output address, we don't have that. Fuck me. Let's make the first one. Hash. That's the key. Get the key. Is this gonna work? What's going on here, please? Run test. It is, right? So we fetch this one. This is the hash of the transaction. Why is this so big? Zero 100 files. That's fine. It's unspent. That's true. And then we can grab the second one. We can if you want, we can grab the second one like this, and that should be the 900 one, right? Yeah, and it's yeah. This is way too big. This I don't know why that is that hash, but it is what it is. Okay. So now we have stored this stuff. That's nice. And we store it because it's a key value store, right? And in a key value store, that's what we need to do. A lot of the time, you can see that they basically construct a key with different things, so we can loop through all. Can we? We will see. I'm thinking, how can we easily find all the transactions from an address? I have no clue, because we need to. We will see. We will see how we're going to fix it. Anyway, we have a way to store our UTXOs right now, which is basically going to allow us to validate that, right? So what we need to do basically each time now. Oh man, this is going to be. So each time we are in chain, we add a block, right? If we add a block, we're going to add this UTXO, which we're probably going to extract in another function. What we need to do is basically, we are going to validate the block, right? Is validate this transaction, right? We're going to verify this. And now what we need to do is check if something like this for out, I think it's input actually. In a range, tx inputs, we need to check if this input is going to be an unspent output. All right. So what we need to do here, because we have the input, the problem is we don't have the address. Okay, cool. So I need to check it out. I need to find a better way. I'm gonna think about this, because the problem is with this input, we don't have access to this. We have access to the hash. We don't have access to the address. So if we don't have access to the address, we cannot fetch it from our we could loop. We could actually loop. We could do it actually. It's gonna take some time, because we can loop through all the outputs. But I don't think it's efficient. I'm gonna because we're already at 30 minutes. We have a lot of setup done, which is good. I'm gonna see how we're gonna make this a little bit better, and then in the next episode we're gonna make this clean, so we can actually do our validation, and also we can use that UTXO stuff. Memory UTXO storage to basically, each time we're going to create a new transaction, we can fetch our UTXOs and use them as input and all that stuff. That's what we're going to do. And we also need to make sure that we set them as spent when we are spending them. But I promise, and then we need to also make sure we have the Merkle root set up, and once we have that stuff, I think we can skip this complex part, because this is complex stuff. I'm not gonna lie. Even for me myself, I need to think about it. But I'm gonna do a little bit of a research so we can do it better. Because a lot of these blockchains, most of the time, a lot of these chains, they do their own implementation of maintaining all these structures, right? I'm gonna see what's the best, and I'll see you in the next episode. Cheers.